Hello. Hello, everyone, and welcome. Welcome to this webinar on congruent and similar triangles. So I'll jump straight in. Okay, so I've done a similar webinar last year, so you can look it up on our YouTube channel, of course. So I've got some questions prepared. Hopefully, I'll be able to demonstrate the approach you take to questions like this. So hopefully well, the outcome of this session is that you understand the logic behind solving these problems. Okay, so we have congruence and we have similarity. So two triangles are congruent congruent if all angles and all sides are equal. All angles and all sides are equal. And they are similar if it's just the angles, right? All angles are equal. Now, that's the gist. That's the gist of shapes being congruent and shapes being similar. We add that all sides are in proportion. Sides are in proportion. But I believe this to be sec. Oh, right. I believe this to be redundant because if all angles are equal, that automatically means all sides are in proportion. I've never seen a scenario where it is not the case, but if somebody could prove me wrong, I would be happy to admit my mistake. But redundant question mark. Okay, so two triangles are congruent or equal if they have two equal sides and an angle between them. Or if all three sides are equal, right? That's an obvious one. So if you have a triangle and another triangle and three sides are equal, side, 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 they're equal. Or if you have 10 centimeters, 12 centimeters, 10 centimeters, 12 centimeters, and the angle between them is also the same, then they're congruent. Or you have the angle, angle, side, or angle, side, angle congruence. So this is where you have two angles and a side between. So for example, you have one triangle, another triangle. This angle is equal to this angle. This angle is equal to this angle. And let's say the side here is the same. So that's angle, side, angle congruence. Or it could be that the side is on this side. So this side is equal to this side. However, or angle, angle, side. If you have these two angles and this side is equal, then they are not necessarily congruent. That's not a thing. So let me do this. Right, so let's look at three different scenarios. Actually, you know what? Let's look at all possible scenarios. Angle, angle, side. So let's do 4. sorry, 5 different scenarios. And here I will delete those. Okay. Right. So side, side, side. That's easy. So if this side is equal to this side is equal to this side, and this side is equal to this side. That's side, side, side congruence. If you have two sides, and an angle between, and this angle is equal to this angle, that's side, angle, side congruence. Now you have angle, angle, side, side. So angle, side, angle. So that's angle, side, angle congruence. Now the next one is angle, 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 side, side. So that's angle, angle, side congruence. Congruence in that order. So angle, angle, side. So they have to be in the same order. Now, I've shown the example where it's not the case. So if you have angle, angle, but let's say this side is equal to this side. So that's not congruent, not congruent. Right. Or not necessarily congruent. They can be, right? But not necessarily. Right. So I hope that makes sense because here we have angle, angle, side, but not in the same order. All right. Good. Okay. And we can delete that. Right. So that's congruence. And then let's do similarity. So with similarity, well, typically you have one triangle is bigger than the other. So you have two angles similarity. So that's angle, angle. If you have two angles equal, angle, angle similarity. Similarity. You have angle, side, side, angle, side, sorry. And side, side, side similarity. Okay, so how does that work? And so side, so let's say this is A, this is B, and this is KA, and this is KB. And the angle is the same. So that is side, angle, side similarity. Similarity. So two sides are in proportion, right? So, and I hope that makes sense. And the final one is side, side, side similarity. So obviously if you have A, B, and C, and this is KA, KB, and KC. So if they are in proportion, so that's side, side, side similarity. Similarity. All right. So two angles, two triangles. Okay. Give examples of congruent triangles. Okay, I think we've covered that. Two triangles have two triangles have equal angles and two equal sides. Are they congruent? So let's look at this question. Well, not necessarily. Let's find an example where this is not the case. Okay, so two triangles are equal angles. So, well, let's do simple one. This is 30 degrees. This is 90, and this is 60 degrees. And let's do another one. 30 degrees, 60 degrees. Okay. So let's say that this is 3. This is 6. Oh. Um, I don't think that will work. Might. Mm, just a sec. And if this is 6, this would be 12. Now, let's say this is 6. If this is 6, this would be x, and this is 2x, so 4x squared minus, so 3x squared is equal to 36. X squared equals 12, x equals 4 root 3. Now that doesn't work. Apologies. Let's try this. Let's try this is 3. And this is 3. Okay, so then this would be square root of 3 over 2. So that would be root 3. Okay, and this would be 9 plus, so root 12. And if you take this side, this is 3. This would be root 3. Nope. This would be 3 root 3. And this would be 3 root 3 plus, so 9 times 327 plus 9, 36 root 36, so 6. And this would be 3 root 3. Sorry, it's not working. I apologize profusely, profoundly. Sorry. Okay, so I had it in my head and then it slipped. So basically, if you have 3 angles equal, so this angle is equal to this angle, and this angle is equal to also equal. And let's say that this side is 3, and this is 6, and this is 6, and this is 12. And you could have Two equal angles and one equal side. I think that's the problem. I think I've copied the question wrong. Because if they have two equal angles and two equal sides, I think they have to be equal. Let me check. Two equal sides. Okay. I have to come back. I apologize. I won't waste any more of your time. Basically, it is possible to have a triangle with two equal sides and three equal angles. Okay, and they're not congruent. They are similar, but they're not congruent. Three, 6, 3 and 6. Okay, anyways, apologies. Problem 2. Show that the angle bisector of an isosceles triangle is also a median in the height. It's not a difficult question, and it might seem obvious to you, but let me follow through a formal approach. So you have an isosceles triangle. Let's say it's ABC, and AC is equal to CB. Equal to CB because it's isosceles. Now the angle bisector, so we draw the angle bisector. This angle bisector of the vertex of opposite. We mean the particular angle bisector, not just A. From the angle bisector of an isosceles triangle, which bisects the two equal sides. Bisects two equal sides. Okay. Now, this is an angle bisector, so let's call it K, CK. We know that this angle is equal to this angle. We need to show that it is also a median. How do we do that? So a median is a line where which CK is a median if AK equals KB, right? So first, proof that it's a median. Proof that CK is a median. Okay, and consider triangle. So consider triangle ACK and triangle BCK. Angle ACK is equal to angle BCK because CK is the angle bisector. So that's a given. Then side AC is equal to side BC because it's isosceles. And then finally, a side CK is equal to itself because it's the same line, right? So side CK is a common side. And because they are equal, this is side angle side. So by side angle side congruence, triangle ACK is congruent to triangle BCK. BCK. Perfect. And that means, hence, AK is equal to BK. And therefore, CK is a median. Okay. 2. Prove that CK is a height or an altitude. Well, because we know so AKB is a straight line. So angle AKB is 180 degrees because it's a straight line. Because it's a straight line. Then we have angle AKC is equal to angle BKC. And that is because the triangle ACK is because the triangles are congruent, basically. Right? And therefore, they add to 180. So angle AKC plus angle BKC is equal to 180 degrees. So 2 times angle AKC is 180 degrees. So AKC is 90. So angle AKC is equal to angle angle BKC, which is 90 degrees, and hence CK is perpendicular to AB. And if CK is perpendicular to AB, then CK is the height or altitude. And now we can use this property all the time because we've proven that the angle bisector of an isosceles triangle, which bisects obviously the which is drawn from the point connecting the 2 legs of the isosceles triangle. So it's also a median and it's also a height. Okay, so this is a useful piece of information, but yeah. Nice. So moving on. In triangle ABC, the median AM is perpendicular to the angle bisector BK. Find AB if BC is 12. Okay, so we're trying to use the formal approach in triangle median AM. So A, B, C, the median AM. So I would move this slightly to make it a bit more scaling. Okay. And a triangle. So M is the midpoint of BC, of course. So AM is the median. So this side is equal to this side. Is perpendicular to the angle bisector BK. Angle bisector BK. All right. So this angle is equal to this angle. And they are perpendicular. So this is a right angle. Okay, the diagram doesn't really show it, but doesn't have to be accurate. So what does that tell us? Well, AB, find AB. If BC is 12. So BC is 12. Okay. And this is a right angle triangle. Okay. All right. So suppose let angle ABK is alpha. So this angle is alpha. And so is this, is also alpha. Then this angle is 90 minus alpha because of the sum of the angles in the triangle. This is a right angle triangle. This is right angle. So this is also 90 minus alpha. Minus alpha. Okay. Then angle BAM is 90 minus alpha. But also angle BMA is also 90 minus alpha. Now consider the triangle ABM. Consider triangle ABM. We can draw it. ABM. And we can see that, well, let's call this point Q. Q. Because this is 90 minus alpha. And this is 90 minus alpha. Angle A is equal to angle M. Hence, triangle ABM is isosceles. And that means that AB is equal to BM. So this side is equal to this side. But we know BC. BC is 12 centimeters, and or what 12, just 12, and M is the midpoint. Hence, BM is 12. Sorry, 6. BM is 6, but AB is equal to BM, which is also 6. So the answer 6. Okay, AB is 6. I hope that makes sense. And let's move on. So this is the way approximately. Yeah, you don't have to follow the rule, but you have to explain every step. When you're doing geometry questions or Euclidean geometry, you have to explain every step of why this is. Okay, problem 4. Show that two different circles cannot have more than 2 points of intersection. Two different circles cannot have more than 2 points of intersection. Okay. I will, so prove by contradiction. By contradiction. suppose we found two circles, two such circles. That means that they have 3 points of intersection, at least 3. So they definitely have 3. They definitely have 3 common points. Okay, so I don't know how this looks like. It's obviously impossible, but something like that, I would imagine. Okay. So 2 different circles, C1 and C2, and they have 3 common points. They might have more, but they definitely have 3. Let those points be A, B, and C. Okay. Now, ABC is a triangle. And if you have a circle passing through C and B, for example, if you have C and B, and you have a circle passing through C and B, the center of that circle must lie on the perpendicular bisector of CB, because this side is equal to this side, and this is the center of a circle, and we already know that in an isosceles triangle, the median is also the bisector, and it's also the height. So we know that this line is the perpendicular bisector. is perpendicular. It bisects CB. So OM is the median, the height, and the angle bisector. Right. So this comes from the property that we have just proven. So the center of any circle passing through CB, C and B must lie on the perpendicular bisector. Of CB. So we draw the line CB, and we find the perpendicular bisector. So the center of both circles must lie on this line. So suppose this is the center. O1 is the center of the first circle, and O2 is the center of the second circle. But if you use a similar argument to AB, so let O1 is the center of circle C1, and O2 circle center of circle C2. Then you do a similar argument for A and B. So if C1 and C2 pass through through A and B, pass through A and B, the center of C1 and C2 must lie on the perpendicular bisect on the on the perpendicular bisector of AB. So we draw AB, and we draw the perpendicular bisector of AB. And the two perpendicular bisectors are not parallel. So L1 and L2. L1 is not parallel to L2. Therefore, they can only intersect at one point. Hence, so the contradiction. O1 must so the centers of the two circles. So O1 must match O2. Centers of C1 and C2 must match. All right, so we know that the centers of the circles must match. That's the first thing. Now, could they have different radius? Well, a very quick inspection will show you that no, because the radius of the two circles must be the same. The radius of the circle must equal to. Well, because AB is not parallel to CB. Because AB is not parallel to CB. Therefore, the perpendiculars are not parallel. So there's a question why they are not parallel. Because AB is not parallel to CB, therefore L1 is not parallel to L2. So that means they can only intersect at one point, and the center of the two circles must match. And then the radius of the circle. So suppose O1, so O1C is the radius of the circle, and so is this one, and then this one. So if O1, O1A is equal to the radius of the circle, and that's it. That's all you need. Must equal to the radius of the circle. So therefore, the two circles so O1 is the common center of two circles. And the radius of the circle is equal to O1A. Therefore, the radius of two circles must match. And you have two circles with matching center and matching radius. It's the same circle. C1 and C2 have the same radius and common center. center. Right. But in the assignment, you won't see a proof. At least we'll mention a proof that a triangle has the triangle has one orthocenter. An orthocenter is the center of the superscribed circle. Right. So if a triangle is inscribed into a circle, and that's the center of that circle. That's it. So that's one way of proving. There's more than one way you can prove the same thing. Okay. Problem 5. Show that if a quadrilateral has 4 equal sides, its diagonals are perpendicular. Well, 4 equal sides, that's a rhombus, right? So basically we need to prove that a rhombus the diagonals of a rhombus are perpendicular. Okay. So A, B, C, D is a quadrilateral. Now we want to show that AC is perpendicular to BD. Show that AC is perpendicular to BD. Well, we know that AB is equal to BC, equal to CD, equal to AD. And what else? What else do we know? We know that triangle. So BC is equal to AD, and AB is equal to CD. And the side AC is equal to side AC. And that means that triangle ABC is congruent to triangle CDA. CDA. So these two triangles are congruent. So this one and this one. By side, side, side. Side, side, side. And that means that angle DAC, hence angle DAC is equal to angle BCA. BCA and angle BAC, this angle is equal to this angle. Angle ACD is equal to CAB. Okay. Now, but that also means that BC must be parallel to AD. BC is parallel to AD because as angle DAC and angle BCA are they're sometimes called this angle. Yeah, alternate angles. Well, you how do you know that BC is parallel to AD? Alternate angles. I'm going to use the fact that they are alternate angles. Right. Because these are alternate angles, then BC is parallel to AD. Now, because they're parallel, okay, that also means that this angle is equal to this angle. And okay. Now, what do I want to do next? I can only show that they are. Oh, of course. Now, let's say the midpoint is M. So now I can use the congruence. So angle BM is equal to DM, and AM is equal to CM. And oh, sorry, what am I doing? Apologies. Angle MBC is equal to angle MDA, and angle MCB is equal to angle MAD, and BC is equal to, yes, so BC is equal to AD. And that means that triangle MBC is congruent to triangle MDA by the angle side angle congruence. And now, because of that, so hence BM must equal to MD. All right. And that means that CM is the median of triangle BCD. So it's a median, and that means that it's a median of an isosceles triangle, which is isosceles. So therefore, CM is the angle bisector of triangle BCD. And also it means that CM is the height of triangle BCD. Right, so if it's the height, that means that CM is perpendicular to BD. And that's what we need to prove. Right. Okay. So as you can see, I only used the alternate angles properties, and I used congruent triangles. That's all that I've used here. Well, the question is, can you use prior knowledge about polygon properties in these questions? Yes, you can refer to prior knowledge, of course. Yes, as long as you know how to prove them, right? Okay. Two angle bisectors in a triangle intersect at 110 degrees. Find the third angle. Right, so we have a triangle. Let's call it ABC. and two angle bisectors. So we have this angle and this angle. They're equal. And the angle bisectors here. So here and here. Okay. And we need to find this angle. Let's call this angle alpha, and this is alpha. This is beta, and this is beta. And this is gamma, and gamma is question mark. That's what we're looking for. And we know that this is 110 degrees. So this is a different style of question. So let's label some BAK and BL and label the midpoint M. Okay. So we straight away know that angle KML is 110 degrees because it's a vertical angles or vertically opposite angles. So this is 110 degrees. Okay. Now we want to find this angle. Angle BKA is going to be 180 minus alpha minus 2 beta. Okay. So let's call it 3. So that's 180 minus alpha minus 2 beta. Now angle AKC, this angle, is going to be 180 minus angle BKA, which is 180 minus 180 plus alpha plus 2 beta. So this is alpha plus 2 beta. Okay. Now, similarly, angle this one, ALM, angle ALM is equal to, considering that this triangle is going to be 180 minus 2 alpha minus beta. And angle BLC, so this angle, so this is 180 minus 2 alpha minus beta. And so BLC is 180 minus angle ALM. So that is 2 alpha plus beta. 2 alpha plus beta. Okay. Finally, consider triangle ABM. ABM. Alpha plus beta plus 110 must equal to 180. That means alpha plus beta is 70. That's good. That's useful. I'm going to use that later on. All right. So now we look at the quadrilateral. We look at the quadrilateral MLCK. Consider quadrilateral MLCK. And so adding all the angles, so 110 plus alpha plus 2 beta plus gamma plus 2 alpha plus beta must equal to 360. Right? So when we're looking for gamma, so gamma is equal to 360 minus 110 minus 3 alpha minus 3 beta. So gamma is 360, so it's 250 minus 3 times alpha plus beta. But alpha plus beta, we already know it's 70. So that's 250 degrees minus 3 times 70 degrees, which is 40 degrees. So the answer is 40. 40 degrees. Okay. Next, ABCD is a parallelogram. M is the midpoint of BC. Find the ratio in which segment MAM splits the diagonal BD into. So we have a parallelogram. A, B, C, D. M is the midpoint of BC. And AM splits the diagonal BD into. So basically, we are looking for, let's call it K, find BK to KD. Okay. So first, draw ML parallel to CD. So ML parallel to CD. And KLMN. So ML intersects BD at point N. 2. Angle BAM is equal to angle AML. Angle BAM is equal to angle AML because it's alternate angles, and similar to this angle. Oop. Angle ABK. Jeez. ABK is MNK. Oh, for the same reason. Alternate angles. And hence, triangle ABK is similar to triangle MNK by the angle-angle similarity. Angle-angle similarity. Okay. Now we can find we're looking for the scale factor, effectively. We're looking for the scale factor of the triangle. So the two triangles are similar. One is an enlarged version of the other. Now, okay. So triangle. Well, here I'm tempted to say that MN is the midline of the triangle BCD. Let's write that down. MN is the midline of triangle BCD. What does that mean? Well, MN is parallel to CD. MN is parallel to CD. And that means that triangle BMN is similar to triangle BCD. And the scale factor is half. So the scale MN to CD is 1 to 2. Therefore, MN to AB is 1 to 2. And hence, BK to KN is 1 to 2 as well. No, sorry, 2 to 1. 2 to 1. So this is 2 and this is 1. Now, but BN is equal to ND. But BN is equal to ND. This comes from the properties of the parallelogram. Can you explain why the scale factor is 1/2? There's a question. Okay. So if you look at the triangle BCD, CD, and the line MN, right? MN is parallel to CD. That means that this angle is equal to this angle, and this angle is equal to this angle. Because M is the midpoint, so BM is equal to CD. BM is CD. That means that BC is twice BM. And that's why the scale factor is 2. Oh, well, 1/2, depending on which way you go. Does that make sense? Okay. Bn is equal to ND, and therefore the ratio of, well, if this is 2, this is 1, so that would be 3. So hence BK to KD is equal to 2 to 4. Oh, I found a much easier solution. Sorry. 2 to 4, which is equal to 1 to 2. Okay. A different solution. So you have the same parallelogram. Okay. A, B, C, D, M. What was that? K. All right. So BC is parallel to AD. Okay, so we know that. And that means that this angle is equal to this angle. So angle MBK is equal to angle KDA because they're alternate angles. And this angle is equal to this angle. So that means that these triangles are similar. Angle BMK is equal to angle KAD. So triangle BMK is similar to triangle DAK. And okay, but BM to AD is 1 to 2 because M is the median, so these two sides are equal. So BM to AD is 1 to 2, and therefore BK to KD is also 1 to 2. Much simpler solution. Sorry. Okay, let me just do one more thing before we finish. And okay, so returning to the very first question. Right, so suppose we have a right angle triangle like this, and we draw a height at the altitude is like this. So let's label it A, B, C, D. And suppose we draw it in such a way that AD is equal to CB. Okay. So now we can consider the triangles separately. Triangle A, ACD. Triangle ACD. This is C, this is D, this is A. And triangle CDB, triangle ACD, so that would be triangle so that is definitely D. And CBD. So this angle must equal to this angle. So A is equal to C. So CBD. So ACD. So CBD. CBD. Okay, cool. Now let's start labeling. So AD is equal to CB. AD is CB. And so these angles are equal. So this angle is equal to this angle. And this angle is equal to this angle. And CD is a common side. So CD must equal to CD. Aha. So yeah, so CD is common side, and AD is equal to CB. So they have two equal sides and they have three equal angles, but they're not the same triangle because obviously, yeah, obviously they're not. Okay, that's the problem that I wanted to do. Okay, let's finish here. So I hope that makes sense. Oh, that is problem one. I've just done it. Shh. Yeah, they're three equal angles. They are. Angle. So this equal to this equal to this, and this equal to this. They're not, that means the triangles, the corresponding triangles are equal. Right. All right. Okay. That's it. So thank you, and I'll see you in 2 weeks' time.